All right, guys, let's go ahead and take a look at Unit 7, Lesson 14. We're going to practice what we've been doing yesterday. So it says, what is or what are the values of y in the equation and inequalities below? Let's go ahead and check these out. Y plus 6 is equal to 10. We all know what to create for there. This is an addition, subtraction problem, so we need to create that type of model, which means we search for the largest value. In this case, the largest value happens to be 10. How do I know that? Because we have to add two things to get to 10, and that is y and 6. So a different way to write this equation is y is equal to 10 minus 6. Y is equal to 4 is the solution. Might be coming back to you now, but how would this look on a graph? I'm just going to draw that really quickly. How would this look on a graph? 0, 1, 2, 3, 4, 5. We know that if y is equal to 4, less than 4. B says y plus 6 is greater than 10. Looks like the same type of model, actually. 10. So instead of an equal sign, we're just going to use an inequality sign. Y is greater than whatever 10 minus 6 is. So y is greater than 4. How does that look? Let's use the same type of graph. 1, 2, 3, 4, and 5. Big difference between the two. One says y is equal to 4. One says y is greater than 4, which means in the second example, y can't equal 4. So we know that there needs to be an open circle here because this is where it starts, but it can't be equal to it. Now, which direction is it going? Well, it's pointing to the right, so let's go to the right. And we just want to put an arrow here to let the reader know that it's any value to the right of 4, which means it's just going to keep going. We're not going to keep going on our paper, but it's just going to keep going. Now let's look at the last one, letter C. Looks the same model, y6, different symbols. It's an inequality now. Y is greater than or equal to 10 minus 6, so y is greater than or equal to 4. So let's see how that looks on the graph. 1, 2, 3, 4, and 5. Now, greater than or equal to, which means it can be equal to, which means we're going to put a closed circle here, and it can be greater than, which means it's not only 4 as a possible value, but it's anything larger than 4 as well. So I'm just going to draw an arrow going to the right to let the reader know, like, hey, it can be any value going in that direction, including 4. So what are the possible solutions here? It's an equation. So for letter A, this is an equation, so it's one solution. Y can only be equal to 4. What about B? B is an inequality, which means Y can be, think of some values Y can be. Y can be 5, 6, 7, 8, and it could just keep going. Now, what about the last one? Y can be same thing as both A and B. It's like A and B put together, where it can be 4, 5, 6, 7, and just so on, anything else. So when it's an equation, one solution. When it's an inequality, multiple solutions, which leads us to our next point. Conjecture. Well, a conjecture is something that you all know already, but I'm just going to go straight to it. Inequalities have more than one solution, so let's write that in. A lot of you are like, duh, but we just need to be reminded. Inequalities have more than one solution. We just witnessed 2 examples above on the think about it. Let's go ahead and test this conjecture. If this conjecture proves to be true, then we will be able to prove that inequalities have more than one solution. So let's see what's happening. What is the solution of the inequality below? Graph the solution. So this is an addition subtraction example. So I'm going to use that type of model. The largest value goes here. The largest value happens to be D. That's created from 6 and 9. So D, and I know a lot of you might want to put equal to, but it's not equal to. D is greater than, remember there's a greater than sign, 6 plus 9. So D is greater than 15 is our mini solutions, not solution. It's our mini solutions, okay? So let's go ahead and figure out how this graph should be drawn. You don't have to start at 0 at this point, but if you want to, that's fine as well. You just have to pick a proper scaling. So I'm gonna go ahead and start at 5. And I'm gonna scale by 5s. So 5, 10, 15, 20, 25. Now, how do we graph this? Do we put a closed circle at 15? Do we put an open circle? Do we just stay there? Do we go in a certain direction? Well, we know we're working with 15, but we know it isn't equal, so it has to be an open circle. And which direction does it go, left or right? Pay attention to where this is pointing. It's pointing to the right, which means it's telling us that is any value larger than 15, I meant. So we just draw an arrow going in that direction, saying that it can be any value going in that direction, not including 15. Did our conjecture hold true? Yes, because this graph shows us that it can be more than one solution for an inequality. Let's try for the second one. What value of H makes the inequality true? So this example is a division multiplication example, which means that model looks a little different, slightly. What number goes into the rectangle by itself? The number that is being divided. In this case, 12 is being divided. So this is a fourth, and a fourth is happening H times. Cool. So we know that H is equal to 12 divided by 1/4. Some of you might have gone and turned this to a decimal. That's okay. Which means you did 12 divided by 0.25. I'll do both examples for you, just so whichever you're comfortable working with, you can just use. So here's an example. Let's see, with fractions first. And then you'll see an example with decimals. So 12 divided by 1/4. I recommend this way because it's kind of quick. Remember, multiply the dividend by the reciprocal of the divisor, which gives me 36. So H is equal to 6. Now, if you wanted to use a decimal, you can do 12 over 0.25. We have to multiply by 100. And 25 goes into 1200. How many times can 25 go into 120? Oh, wait, did I do something wrong? Oh, guys, yep. That's not supposed to be a 36. It's a 48. My mistake. So 4, which makes it 108. Okay, so we just verified that it is 48. But remember, guys, we're falling for a misconception again. And I'm glad I fell for it as well. So now you can see that it's really easy. H isn't equal to that. H is greater than or equal to that. Okay, if I can fall for the misconception, you definitely can. So now we have to make sure we graph the solution. And just like the previous one, we want to make sure that our scaling is correct, our range is correct. So I'm going to go ahead and pick, I'll pick 12. I can start at 0 or I can start at 12. I'm just going to scale by 12. And pick a number where you know it can fit on your paper and that you can easily scale by. Okay, so this says greater than or equal to 48, which means it can be equal to 48, which means I'm going to actually put a closed circle here. Now that I have a closed circle there, what I can do is determine what direction I'm going, and it looks like it's pointing to the right. It's also saying that anything greater than or equal to 48, which means I am selecting anything greater than or equal to. And our conjecture holds true because we have more than one value, more than one solution, okay? So let's get some practice in with these, guys.